All right, this is the backside of Momentum review page or packet. It's number 3450 if you're looking at the front side of it. The first question, or seventh question, mother pushes her 120 Newton child sitting on a swing. If the mother exerts a 10 Newton force on the child for 0.5 seconds, what's the magnitude of the impulse? The impulse is J, and it's F times delta T. Sometimes it's just F times T is what it's shortened to. So the 120 newtons is just extra information. The force that she's exerting is 10, and it's for 0.5 seconds. So the answer is 5 Newton seconds. Whoops. How do I undo? There it is. 5 Newton seconds. I'm just not even going to try and write it and just circle it. This is common. You guys got to be careful of these things where there's this extra information. Just don't get in the habit of, oh, there's newtons, there's time. Let's multiply them together and get an answer. Think about what force is being applied to cause the impulse. The weight of the child has nothing to do with the impulse. Excuse me. Next question. Tenth of a kilogram model rocket's engine is designed to deliver an impulse, J, of 6 Newton seconds. The rocket engine burns for that much time, 3/4 of a second. The average force it produces, again, J equals F times delta T. J is 6 Newton seconds. The force we don't know, and the time is 0.75 seconds. If you solve for F, it's 6 divided by 3/4, or the same as times 4/3, right? 0.75 is 3/4, so if I divide by 3/4, it's the same as multiplying by that. 1, 2, the answer is 8. 8 newtons. Next question, number 9. Bullet traveling at that speed is brought to rest, so that's V final is 0, by an impulse of that much, so that's J. What is the mass of the bullet? When you're given velocities and forces, you probably want to think of MAVFAT, M delta V equals F delta T. We don't know the mass of the bullet. We know the change in velocity of the bullet. It's going from V final is 0, and V initial is 5 times 10 to the second, which is 500 meters per second. Remember, it's always final minus initial equals force times time, but we don't know the force, we don't know the time, but we know the combination of the two. So we actually have this quantity. That's 50 Newton seconds. And it doesn't say it in the question, but you kind of have to understand that this is a negative number. It's being brought to rest. So it's causing it to slow down. The force times time has to be in the opposite direction. So that negative has to be in there. If you didn't do that, you'd basically be dividing negative 500 into 50, and you'd get negative, 0.1 kilogram. Negative doesn't make any sense for mass. So you're not just crossing it out and say it doesn't matter. You realize that this should have been a negative number. So 0.1 is 1 times 10 to the negative 1. Again, a lot of scientific notation questions here that you got to make sure you understand. All right, you have a mass of a bullet fired from a rifle by an unbalanced force. So you have F, you have M. If the force acts on the bullet for that time, what is the maximum speed attained by the bullet? You could probably assume that V initial is 0. And you want to know V final. Delta V, M, F, and T. It's another MAVFAT question. M delta V equals F delta T. If we plug in everything and do the math, I don't know if I can do this in my head, and I have no calculator. This delta, I'll just leave it as delta V. It's coming from 0, so whatever my answer is going to be that maximum attained speed. F is 200 newtons, and it's 0.1 seconds. So that's 20. Delta V equals 20. I'm going to divide the 0.025 over to this side. So that's the same as 25 hundredths. So dividing by 25 hundredths is the same as multiplying by 100 over 25 thousandths is the same as multiplying by 100 over 25, 1,000 over 25. Yikes. You guys can just do the math with a calculator. I'm trying to do this here. This is, what is that, 40? 40 times 20 is 800. And it's not an answer. Oh, it is an answer. I'm looking at the wrong one. So C is your answer for that. Double check my work. What's the magnitude of the velocity of a 25 kilogram mass that's moving with a momentum of 100 kilogram meters per second? So this should probably be the first question. P equals mv. The momentum is 100 kilogram meters per second equals 25 kilograms times v. V, I think, is equal to 4. Pretty simple. You guys are going to get in the habit of doing the whole m delta v equals f delta t. You don't have to do that on every single question. If they ask you what the momentum is, just do m times v. If they ask you what the impulse is, just do that. Right? It's not complicated every single time. So if it's a simple question and you're sure it's simple, answer it simply. That's great advice, right? All right, next question. A 20 kilogram cart traveling east. So I have a cart going this direction. Just draw it as a box with a certain speed, 6 meters per second. So this is 20, this is 6. I know the momentum of that is 120 then. It collides with a 30 kilogram cart, 30, traveling west. We don't know what that velocity is. If both carts come to rest immediately after the collision, what was the speed of the westbound cart? So this is a conservation question. P before equals P after. M1 V1 plus M2 V2 are our two carts before. To see what happens after, we got to read the question. They both come to rest. So it doesn't matter if they bounce apart, or I guess don't stick, which is what this equation would do, or if they do stick, this is what your second side of your equation would look like. It doesn't matter which of these two happens in this case because it says they both come to rest. Either way, this side of the equation becomes 0. So M1V1 is, what did we say, 20 kilograms times 6 meters per second. Plus, I'm going to erase 30 kilograms times V2 equals 0. Remember, they both came to rest afterwards, so this is 0. 120 equals negative 30 V2. V2 equals negative 4 meters per second. That's not an answer, because they're looking for the speed, which again is just the magnitude of it. So the answer is 4. Why is that negative important? It's going in this direction here. This one is going at positive 6. Negative 4 just means the opposite direction. All right, number 13. This one's taking a little bit longer. Sorry about that. Number 13 says an 80 kilogram skater and a 60 kilogram skater stand in the, so they're going to explode apart. The 60 kilogram skater moves with 10 meters per second east. So 60 times 10 going this way. So their momentum is 600 kilogram meters per second. The 80 kilogram skater goes west, obviously. So that's got to be, west has to be the answer. At what speed? So 80 times V of the second skater has to equal 60 times 10. P before equals P after. 0 doesn't equal 0. 0 equals P of the one skater plus P of the other, which means P1 is equal to negative P2. So 600 divided by 80 is what V is. I believe it's 7.5 west. 2 more questions and then we're done. Whoops. The mass of a space shuttle is approximately, well, that's a big number, 2 times 10 to the 6th. So 2 million kilograms. During liftoff, the net force on the shuttle is that. So we have F, we have M. What is the speed of the shuttle? We have a T. Looks like we're in for another math fat. You want to know what the change in speed is given a force and a time. So 2 times 10 to the 6th times V equals 1 times 10 to the 7th times 10 seconds, which makes this side 1 times 10 to the 8th. So V is equal to 1 times 10 to the 8th divided by 2 times 10 to the 6th, which is, I believe, 5 times 10 to the, what is that? This would be 10 times 10 to the 7th. So it would be 5 times 10 to the first, or 50 meters per second. Again, double check my work. It's amazing how when you rely on a calculator, you just can't do simple math. But I think that's that. Last question. Momentum of an object is the product of, how can this not be the first question? Mass and velocity. P equals mv. All right, in review for tomorrow, you have to know sort of basic definitions of P, of J. Maybe I should just get rid of everything here. P equals mv, J, F delta T. The fact that J is the same as delta P, and that means delta P, based on this definition, is M delta V. That's all your basic momentum definitions. They're vectors also, I forgot that. These are also vectors. So you'll have sort of basic questions on this. You'll combine this. You know, if J is F delta T and delta P is M delta V, this is where math fat comes from. Okay, so this will be sort of half the test. The other half of the test will be about conservation. And P before equals P after is not the most helpful formula. Like, you can't just solve this, but you have to rewrite it. And V1 plus M2, V2, and then it's like, what happens if they combine and stick together in inelastic collision where they're sticky, perfectly inelastic? Then you have some V combined prime. This prime means after, just notation. Or it could equal M1 V1 prime plus M2 V2 prime, where you have these separate bouncy things. In class, we talked about an elastic collision. I'm not sure that's going to make it on there. That just means that the KE is conserved. And that gives you an extra equation to use. I think it's V1 plus V1 prime equals V2 plus V2 prime is the shortcut for that. That's helpful, but I don't know that you're going to have to definitely use that tomorrow. The last thing, which you saw a lot in the review, was that we do a lot of explosions, which P before still equals P after, but before is 0. And the after is P of one plus P of the other. It has to sum to be 0. So basically you have equal and opposite. This is what the recoil is from the cannon that's fired or a rifle that's fired. So basically you have M1 V1 prime equals M2 V2 prime, and one of them has to be in the opposite direction. So this V or this V has to be the opposite of the other one. I hope this helps, and I hope you study. If you did and you enjoyed this, comment, so I feel better about myself, because it's very frustrating to spend a half hour, 45 minutes of my time to have 10 people watch this. So enjoy, and you're welcome.